ನಮಗೆ ಬೇಜಾರಾಗಿರ್ತದ ಹೌದು ಹೌದಪ್ಪ ಏನು ಮಾಡ್ತಾರೆ ಇಲ್ಲೇ ಆಮೇಲೆ ಡ್ಯೂಟಿನ ನಿಮ್ಮ ಆಸ್ಪತ್ರೆನ ಮನೇನ ಓಹೋ ಹೆಂಗಿರ್ತೀನಿ ನಾನು ಪಾಠನೂ ಮಾಡಬೇಕಾದ್ರು ಓಹೋ ಆಮೇಲೆ ನೋಡ್ಬೋದು ನೀನು ಹಾಸ್ಪಿಟಲ್ಗೆ ಹೋಗ್ಬಿಟ್ಟು ಅಂದ್ರೆ ನಿಮ್ದು ಟೀಚಿಂಗ್ ಹಾಸ್ಪಿಟಲ್ ಅಂತ ಕರೀತೀರಾ ಹಾಂ ಟೀಚಿಂಗ್ ಹಾಸ್ಪಿಟಲ್ ಮತ್ತೆ ಎಷ್ಟು ಗಂಟೆ ಏನು ಡ್ಯೂಟಿ ಅಲ್ಲಿ ಹೋದ್ರೆ 8 hours
Hello friends, welcome back to my channel. ನಾನು ಶ್ರುತಿ. Friends, ಈಗ ಆಲ್ರೆಡಿ ನೀವು ಇನ್ವೆಸ್ಟಿಗೇಷನ್ಸ್ ನಲ್ಲಿ ಈ ಸಲ ಹೊಸದಾಗಿ ಬಂದಿರುವಂತ ವರಮಹಾಲಕ್ಷ್ಮಿ ಟವರ್ಸ್ ನ ನೀವೆಲ್ಲರೂ
ಈಗ ಡ್ಯೂಟಿ ನೀಟಾಗಿ ಮಾಡ್ಕೊಂಡು ಮತ್ತೆ ಯಾವಾಗ ಬರ್ತೀರಾ ಮೊಬೈಲ್ ಬರುತ್ತಲ್ಲ ಯಾವುದು ತುಂಬ ದಿನ ಆಗುತ್ತಲ್ಲ ಈಗ ಮತ್ತೆ ಹೌದು ಮಧ್ಯದಲ್ಲಿ ಜುಲೈ ಹದಿನೈದರಿಂದ ಹಾಂ ಹೌದು 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 ರೈಟ್ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಹ್ಯಾವ್ ಎ ನೈಸ್ ಡೇ ಟೇಕ್ ಕೇರ್ ಓಕೆ
Karthik, unmute yourself and tell me the screen is visible and audible.
Yes, sir.
Yes, okay. We will discuss some important things about the test. So the portions which are important for the test, we will discuss one by one. First, come to the point. Resistance welding, resistance furnace. See, the resistance furnace works on the principle Q equal to I squared into RT, where Q is the heat developed in joules or resistance of the coil in ohms, and T is the time in seconds. So this is the principle adopted in resistance furnace for melting of maybe ferrous and non-ferrous metals of small quantity, ranges from 1 kg to 50 kgs. All of you observe here the resistance furnace, and you have the notes and also the video of this resistance furnace, so which contain the crucible. Crucible is nothing but the ladle, so which contains the liquid metal and which is covered by steel cover, which is called lid, and the cover has a vent holes in order to make the gases coming from the liquid metal made to escape out through the vent. And all of observe here, this is the resistance coil, and there will be a block which is made of concrete on which the crucible is placed. The crucible is made of usually the carbon or some type of material which is mixed with chromium and carbon. And the principle of operation, once if you switch on the current to the resistance furnace, the steel shell which contain the coil which produces ohmic resistance, remember ohmic resistance, that resistance produces the heat in the, you all already studied the in ohmic resistance, that is Q equal to I squared into RT. Q is the heat developed, R is the resistance of the coil, and T is the time in seconds. So in a few minutes, 2 to 30 minutes of 100 kgs of metal in the crucible are melted in 2 to 3 hours. So after 3 hours, they open the lid and see the color of the metal, and they switch off the electric current. They take out the crucible from the furnace, and the metal is ready for pouring. This is the principle of operation of resistance furnace. And let's come to the point. This is also called as ohmic resistance heating furnace. Next, come to the point, induction furnace. Why it is called induction furnace? Many of you have induction stove in your house. All of you seen that? Now, what is the principle of operation of an induction stove? If you switch on the induction stove, ohmic resistance, there is no contact between the container and the stove. The ohmic resistance is developed around the container. Due to that resistance, heat is developed. That heat is utilized for boiling of food or preparing of food. In the same way, all of you observe here the coreless induction furnace. You leave coreless, you write the induction furnace. Induction furnace. So what is this induction furnace? Say you go through the bottom of the induction furnace, which is made of bricks. The bricks are made of refractory material. All of you seen the bricks used in construction of the house, the same type of material, but it has a property of the temperature control and heat transfer, which hold the temperature or heat in the furnace for a longer period, which will not allow the heat transfer from the induction furnace to the outside. That is the property of the refractory lining and also the brick lining made in the bottom of the induction furnace. All of you observe here what all the parts are present in induction furnace. This is the crucible. The crucible means it is a container or ladle which contain the liquid metal or molten metal, and along with around the crucible, along the ladle, the wire coil. All of you observe here the coil, the primary, it is called as primary circuit or primary coil, which is covered around the ladle and which is placed inside the steel shell. In between the crucible and the steel lining, steel shell, there will be a refractory material which is made of silica sand or crystals of silica, are placed in between the ladle and the steel shell, and bottom you have a refractory lining construction or bottom refractory brickwork. And all of you observe it, this is very, very important. Hinge. Once the metal completes the solidification, the melting process, the complete metal is poured into the ladle through the lip of the furnace. So there will be a hinge, there will be a mechanism. By using crane, the entire furnace is tilted 180 degrees centigrade so that the liquid metal directly poured into the ladle. Then the ladle is carried to the molding section where the metal is poured into the mold cavity. This is the principle of operation of coreless induction furnace. You can write the same thing for induction furnace. Next, come to the point. Direct arc furnace. And then see, there will be 3 electrodes which are connected to the power supply, 3-phase power supply, and these graphites are made of pure carbon, that is called graphite, pure carbon graphite, and there will be a magnesite brick lining or brick wall. On that they place the shell which carries the 3 electrodes made of carbon or graphite, and this is the molten metal placed inside the ladle or container, which is placed on the refractory brick construction. All of you observe here, this is refractory brick construction on which you have the container. Suppose if you want to melt aluminum alloy or stainless steel or copper alloy or low carbon steel or medium carbon steel or high carbon steel, the scrap along with the steel metal pieces are placed inside the container. Once if you switch on the electric power supply, the spark generated between the electrode and the liquid metal, and this arc is maximum enough, which has the heat maximum enough to melt the stainless steel, low carbon steel or alloy steel. That arc has the temperature of 2800 to 3000 degrees centigrade, which is maximum and which is enough heat which makes the metal to become liquid. Once the metal completes its melting process, then the metal is ready. That is nothing but, if it is stainless steel or if it is low carbon steel or alloy steel, when the liquid metal turns to yellowish orange color. All of you remember, write down a word, yellowish orange color. In case of alloy steel, low carbon steel, and some ferrous metals, cast iron with chromium, tungsten, vanadium, and molybdenum alloying elements. These alloying elements, if present in the cast iron, when the liquid metal turns to yellowish orange color, that indicates the temperature of the liquid metal is 1400 to 3000 degree centigrade. All of you write down a word. Remember, in your lifetime, the color of the liquid metal of stainless steel, alloy steel, cast iron with chromium, tungsten, vanadium, and molybdenum as alloying elements, then the color of the liquid metal is yellowish orange. All of you please write down the words yellowish orange. That indicates the metal is ready for pouring. Metal is ready for pouring. So this is the indirect arc furnace. See here, there will be a roller. The entire furnace along with the liquid metal, which is turned 180 degrees in order to remove or in order to pour the liquid metal into the ladle. Next, write down cupola furnace. Very, very important, not only for this semester, throughout your life, you have to remember the cupola. The diameter of the cupola is around about 10 to 50 meters diameter, of height 1000 meters or even high. Just imagine the diameter of the cupola is in your classroom size, and the height may be the 100 meters or 50 meters height. So that is nothing but, you might have seen TV tower. You might have seen the TV tower, not that much of height, of 50% of that, 50 meters height, and the diameter usually 10 meters or 20 meters, and which is made of steel shell, and please, all of you, go to the YouTube and see the principle of operation of cupola. See the principle of operation of cupola in YouTube. So you can learn a lot of things from the video. Say, in your fate or the fate of Bhadravati, VISL, in VISL, the best quality cast iron is produced in VISL. That's in the year of 90s or 80s. That time, the cupola furnace they used for producing of best quality of cast iron. Now that cupola is closed. If we visit the VISL, you can see the cupola, how the cupola is made, what all the requirements of the cupola. It is a diametered steel shell which has three layers of coke, flux, and metal. Coke, all of you seen, the coke used in railway locomotive engine, and flux is the calcium carbonate, that is nothing but the sunna, we call it as in Kannada sunna, calcium carbonate, and the metal is iron ore, iron ore along with scrap.
So many students are waiting to join, sir.
Uh, ask them to join. Join Adra. See, the cupola furnace produces a pure form of cast iron. The easy method, economical, and you can produce the tons of million tons of cupola, million tons of cast iron from cupola. But the thing is, once the cupola is started, it should be continued.
ಹಲೋ ಸರ್ ವೇಟಿಂಗ್ ಮಾಡಕ್ಕೆ ಹೇಳ್ತಿದ್ದಾರೆ.
ಜಾಯ್ನ್ ಆಗಿ ಕೇಳಮ್ಮ ಬೇಗ. Okay, join Adra. Okay. The cupola furnace produces the pure form of cast iron. Remember, the limitation of the cupola is once you start producing cast iron from cupola, it should continue to produce the cupola 24 into 7. Remember, this is very, very important. 24 into 7. That is nothing but the cupola produces continuously the cast iron of pure cast iron, which contains the carbon 2 to 6.67%. 6.67%. And all of you observe here, cupola contains 3 layers: coke, flux, and metal. This is the platform on a lift which moves up and down, carries the coke, flux, and metal, and through the pushing JCB or poke line, they push the coke, flux, and metal into the chamber, stainless steel chamber, which has the 3 layers. All of you observe here: coke, flux, and metal. Coke, flux, metal. Like this, 3 or 4 layers, the mixed with 3 layers of stage 1, stage 2, stage 3, stage 4, stage 5, like that. Each stage has 3 layers. And then all of you observe here the tubers. Tubers is nothing but the pipes which supplies the hot air that is coming from the huge blower. So if you next week onwards, you may visit the Smithy section. There you can see the blower of small size, the same type of blower with huge capacity of producing air into the high pressure air is supplied to the cupola through the tubes. Tubes means it is a tube or pipe which supplies the air. Once the coke is ignited, which makes the metal and flux liquid, melts the flux and metal, and the cast iron is ready. And due to gravity, the cast iron is collected at the bottom. On the top of the liquid cast iron, there will be slag, that's the waste material is present, that is removed from the slag hole, and the pure cast iron is removed from the drop down bottom door and collected in the ladle and poured into the shells or poured into the flakes, just like a flakes which is poured into the openly into the flakes. Otherwise, sometimes directly they pour into the mold box. But this is the raw material coming from the cupola as cast iron that is used for raw material for further manufacturing process. One thing all of you remember, the carbon dioxide formed here, which is converted into carbon monoxide, which is released to the atmosphere through the chimney. This carbon dioxide and carbon monoxide has the temperature of 400 to 500 degrees centigrade. That heat is utilized for heating of the coke and flux and metal. Preheating of the coke, flux and metal are preheated, then which is placed inside the cupola shell, and also the air is supplied to the cupola, also heated by using the same carbon monoxide and the carbon dioxide coming from the chemical reaction between the coke, flux and metal, which is collected and supplied to the two airs, where the hot air is converted into hot air, then it is supplied to the cupola through the tubes. See, one thing, this is the continuous process of producing cast iron 24 into 7. You can produce the cast iron 24 into 7 is possible. This is a very, very important, the examination point of view, as well as in competitive examination. You may have the question from the polar chapter in the competitive examination. Almost all the competitive examination, you see that you have a 10% of questions are coming from cupola. Next, come to the point, different zones of cupola. See, the different zones of cupola, this is also very, very important. The well zone, where the 3 layers of coke, flux and metal is placed, and the liquid cast iron is collected in the well zone. Next, come to the point, combustion zone. Here, the combustion of coke, which melts the metal and flux and convert the metal into liquid metal. And reduction zone, this is the carbon dioxide coming from the chemical reaction is converted into carbon monoxide and used for heating of the flux, metal and coke, and also use this carbon monoxide has the temperature of 200 to 400 degree for heating of the air, which is supplied to the cupola through the tubes. This is the preheating zone. As I told you, the air is mixed with carbon monoxide, which has the temperature of 200 to 400 degrees centigrade, which is used for preheating of the coke, flux and metal. Next, all of you go through the carbon dioxide molding process. So what is the special in this molding process? Only thing is everything is same. You can use the carbon dioxide for conversion of silica sand into the rock-like structure, which produces sodium silicate, which produced from sodium silicate, which converts the silica gel, SiO2 plus Na2CO3 is the silica gel. So all of you seen the synthetic resin game, synthetic resin gum, you all of you call it as Fevicol, the formaldehyde solution, so which has the property of bonding of sand particles. This may be the silica sand or some type of a silicate binder used to bond the sand particles. This makes the sand into rock-like shape or rock-like structure. So that's possible. So once if you complete the molding process, placing of sprue and riser, after making the vent holes, supply the carbon dioxide into the mold cavity so that the chemical reaction takes place and produces silica gel. Silica gel is just like a gum or adhesive which makes the bonding of sand particles. Sand particles. Next, come to the point, high pressure die casting. This is also called HPDC process, high pressure die casting. See the pressure of all of you, imagine the pressure of 7 to 500 Newton per millimeter square pressure used in this process. How do you produce this pressure? Through the air compressor, multi-stage air compressor, you can produce high pressure air and supplied to the die casting machine. So this is the casting shape. One is fixed block, other one is moving block. If you match these two blocks, you have the die cavity. Inside the die cavity, the liquid metal is pressurized liquid metal forced into the die cavity, and which fills the die cavity with the metal. For this good example, all of you use plastic tumbler, plastic mug, plastic jug, and tub. Many more items are manufactured from PVC or plastic material. High pressure die casting is very, very important for human being because almost all the components which we use in our house which made of plastic. So those plastics items are produced from high pressure die casting process. Next, come to the point, very, very important thing, the solidification. The solidification is the process of converting liquid state to solid state. That phase transformation from liquid phase to solid phase. How do you define? That is nothing but due to heat transfer from the liquid metal to the bottom of the mold, liquid metal to the wall of the mold box, and liquid metal to the surrounding. The heat transfer takes place, which makes the solidification process. And the solidification process can be explained with using three steps. One is the nucleation process, crystal growth, grain boundary. Nucleation process means a nuclei appears, attract the neighbor nuclei, and grow in size, reaches the maximum size, and then attract the neighbor nuclei and forms the crystal growth. It looks like a antenna. in the previous method of distribution of signal from low power transmission and high power transmission, TV towers transmit the signal from the TV center to the our house. The same for that, if you want to receive the signal, you have to use antenna. The antenna type of structure is formed in the liquid metal and grow in size, that is called crystal growth. And after completion of crystal growth, which makes the grain boundary like this. Grain boundary like this. Go through the three diagram: nucleation, crystal growth, and grain boundary. All of you observe here the SEM, scanning electron microscope. The photograph was taken from the conversion of liquid phase to solid phase. This is the actual photograph of aluminum alloy. That's in 1 millimeter. Looks like an antenna structure in 4 directions. How it was, that is the interface between the heat metal and the surrounding. In X and Y direction, this is the critical angle. This is the alpha. This is the diagram for aluminum alloy, diagram for iron. Next, come to point, all of you write down. All of you already have a detailed explanation about solidification. One is directional solidification, other one is progressive solidification. Directional solidification means it starts from the mold wall in this direction, and the progressive solidification is the heat transfer between the liquid metal and the wall. This is also called as parallel wall solidification process. This is very, very important, and all of you mark it. Solidification is classified into two. One is directional solidification, other one is progressive solidification. Next thing, very, very important, the gases absorbed in the liquid metal should be removed. What all the methods are available? How the gases are absorbed in liquid metal? Due to chemical reaction between the moisture in the mold cavity and the chemical reaction between the material used as the alloying element, the carbon monoxide, hydrogen, oxygen, nitrogen. These gases are absorbed in the liquid metal as gas, not molecules. These gas should be removed through the flushing of inert gas, argon and neon into the liquid metal, so that the bubbles coming from the bottom of the pipe which carries the gas present in the liquid metal. And next, the vacuum degassing, the common method used in foundries, ferrous and non-ferrous foundries. That is they create the vacuum chamber, then they place the ladle along with the liquid metal like this, and they make the vacuum so that the gases present in the liquid metal are escaped out through the vent. This is the commonly used degassing method in foundries. So static bath gassing also, it is one of the vacuum degassing method. Induction degassing is also a vacuum degassing, but the thing is they use the induction coil for degassing of liquid metal. And droplet, pour the droplets of liquid metal into the ladle in the vacuum chamber, which also makes the degassing of the liquid metal. Fractional degassing, by passing the argon gas into the container, into the ladle, which divides the liquid metal into fraction or tiny droplets. Due to that, the gases present in the liquid metal can be removed. And fettling and cleaning of casting. See, as the castings is coming from the foundry which has gates, ingates, risers, runners and all those things are removed by using chiseling operation or cutting operation, by using gas cutting or grinding wheel, and using some other method they cut the risers, gates and other unwanted projections from the casting. And cleaning of casting, all of you heard shot blasting or sand blasting. Keep the castings in a shell, steel shell. There will be a provision of a circular disc on that circular table. On that you place the castings, which rotates in the clockwise or anti-clockwise direction. The castings are hit by small balls or the casting hit by sand, so that the surface of the casting are cleaned by shot blasting machine. Now I stop at this stage. I wish you, all of you, all the best for the coming test. Now, all of you, please write your name and USN in the chat box and answer roll call. All of you unmute yourself. Karthik MK.
Yes, sir.
Pratik S.
Yes, sir.
Karthik R. Chandan.
Yes, sir.
Prema.
Yes, sir.
Abhiram.
Yes, sir.
Manoj YB.
Yes, sir.
Harsha MR. Harsha MR. Adil SU. Jayant L. Nazma. Kumaraswamy. Gaurav KL. Abhilash. Vignesh. Nikhil Gowda.
Yes, sir.
Mohammad Raja.
Yes, sir.
Atal B. Kurtik K.
Sir.
Akshay M. Patil. Mohan Raj. Prathamesh.
Present, sir.
Prathamesh.
Present, sir.
Okay, ma. Okay. Prathamesh. Prathamesh.
Present, sir.
Bhairappa Hegde.
Present, sir.
Harshavardhan.
Yes, sir.
Jishan.
Present, sir.
Aditya J. Dhanush. Manoj H.
Present, sir.
Dhanush. Nazma Khanum. Nishchit Gowda.
Sir, Malhar Vivekanand.
Present, sir.
Malar Vivekanand present. Okay. Nishchit Gowda.
Present, sir.
Sir.
Vignesh. Vignesh. Mohan Raj. Ganesh Naik.
Present, sir.
Okay. Anybody else? Please tell me your name. Karthik. Okay.
sir.
Karthik.
Kumaraswamy. Okay. Kumaraswamy. Okay. Okay. Next.
Sir, Karthik.
Karthikar. Okay, ma. Okay. Okay. Next.
Sir, Abhilash.
Abhilash. Okay. Next.
Sir, Mohammad
Anybody
Raza.
else? Mohammad Raza. Okay.
Sir, Nishchit Gowda.
Anybody else? Nishchit Gowda. Okay, ma.
Mohan Raj.
Mohammed. Okay. Anybody else? Now I stop at this stage. I will continue in the next class. And all the best for the test. And I will send the link for that. You upload the scanned or photo of your answer test sheets.